Have you ever stood at the edge of the sea, watched the waves roll in, tasted the salty spray on your lips, and wondered, why is the ocean salty? Why not sweet, or bland, or even bitter? And more curiously, what if the ocean wasn't salty at all? What if it was just water? Let's dive beneath the surface of this mystery. To understand why the ocean is salty, we have to go back, way back. Over 4 billion years ago, when the Earth was still young, it was a planet of fire, magma, and chaos. Volcanoes roared across the surface, spewing gases into a fledgling atmosphere. Among those gases, water vapor. As the planet cooled, the vapor condensed, and it rained. Not for hours, not for days, but for thousands, perhaps even millions of years. The Earth's first oceans were born from this relentless rain. But here's the catch. This newborn water wasn't salty. It was relatively pure. So where did all the salt come from? The answer lies in weathering a slow, powerful force that has shaped our planet for eons. As rain fell on the land, it wasn't just water anymore. It became slightly acidic, absorbing carbon dioxide from the air and forming a mild carbonic acid. This acidic water flowed over rocks, dissolving minerals and carrying ions, tiny charged particles, into rivers. And rivers, over millions of years, poured these minerals into the oceans. 2 ions became especially common, sodium and chloride. Together, they form sodium chloride, common table salt. And while rivers also bring calcium, magnesium, sulfate, and other ions, sodium and chloride dominate. Over billions of years, these minerals accumulated in the ocean. Today, if you took a gallon of seawater, you'd find about 35 grams of salt, roughly 3.5% by weight. Multiply that by the vastness of all the oceans, and you're looking at over 50 quadrillion tons of dissolved salts. But the story doesn't stop there. You might wonder, why isn't the ocean getting saltier and saltier? After all, rivers keep bringing in more salt, right? It turns out, the ocean has its own slow-motion regulatory system. Some salts precipitate out as minerals and settle to the seafloor. Others are used by marine life to build shells or coral skeletons. Some are trapped in seafloor sediments or hydrothermal vents, where superheated water at mid-ocean ridges reacts with the seafloor and removes magnesium, sulfate, and others. In essence, the ocean has reached a dynamic equilibrium. Salt comes in, salt goes out, and over time, this balance has stabilized the average salinity. But now, let's play with reality. What if the ocean wasn't salty? Imagine waking up one day and every ocean, sea, and saltwater body across the globe had become as fresh as a mountain spring. No more salt, just pure HO. What would happen? 1. Mass marine extinction. The first and most devastating effect would be on marine life. Fish, plankton, crustaceans, corals, everything in the ocean has evolved to survive in salty water. Their cells are adapted to a specific osmotic balance, the flow of water in and out of cells due to salt concentrations. In freshwater, that balance is destroyed. Saltwater fish would rapidly absorb water through osmosis, their cells swelling and bursting. Coral reefs would bleach and die. Microscopic plankton would vanish. The base of the food chain would collapse. A global mass extinction would begin, almost immediately. 2. Weather and climate chaos. The ocean's saltiness affects more than just biology. It impacts physics. Salt water is denser than fresh water. It also freezes at a lower temperature. These properties are crucial in driving thermaline circulation, a global conveyor belt of ocean currents powered by differences in temperature and salinity. If the oceans became fresh, this circulation could grind to a halt. The Gulf Stream, which brings warm water to northern Europe, could weaken or stop. Northern latitudes might plunge into cold, while the tropics bake. The ocean helps regulate the Earth's climate. A sudden change in salinity could throw our weather patterns into chaos, destabilizing monsoons, altering rainfall, and increasing the frequency of extreme weather events. 3. Collapse of the carbon cycle. The ocean is also the planet's largest carbon sink. It absorbs about a quarter of the carbon dioxide we emit. Much of this absorption depends on the ocean's chemistry, its pH, temperature, and salinity. Without salt, the ocean's capacity to absorb CO would change. This would accelerate climate change. The atmosphere would warm faster. Ice caps would melt more quickly. Sea levels would rise, ironically, even as marine ecosystems perish. 4. No more salt harvesting on a more human scale. Vast industries depend on extracting salt from seawater. Salt is more than seasoning. It's used in chemical production, de-icing roads, preserving food, and even in pharmaceuticals. If oceans went fresh, these industries would collapse. Millions of jobs would vanish. New sources of salt, like mining halite or evaporating inland salt lakes, would struggle to meet demand. 5. You'd float less. Ever tried floating in the Dead Sea? It's easy because high salinity increases water's density. In fresh water, your body is less buoyant. Swimming in a fresh ocean would feel different, harder. Sinking would be easier. Drowning risk? Possibly higher. But the scariest consequence? The planet wouldn't smell the same. No more sea breeze. No more briny scent. The sensory signature of Earth would change. It wouldn't feel like home anymore. Could humanity ever remove the salt from the ocean? Technically, yes. Through desalination, a process used in arid nations to produce drinking water. But desalinating the entire ocean would require more energy than our civilization can generate. Just to put it in perspective, desalinating 1 cubic meter of seawater takes around 3 kilowatt hours. The ocean holds 1.35 billion cubic kilometers. That's a number with 21 zeros. We'd need more energy than the sun gives Earth in a year. In other words, no, it's impossible. But nature has tried. During the last ice age, as glaciers locked away fresh water, ocean salinity increased. When the ice melted, it added fresh water, temporarily reducing salinity in some regions. These changes disrupted ocean currents and possibly triggered cold spells in Europe. Salinity matters, more than we often realize. If the ocean's salt levels change, even slightly, it signals something bigger. Melting ice, changing rainfall, altered currents. That's why scientists monitor ocean salinity from space. Using satellites like NASA's Aquarius or SMAP, changes in salt concentration can tell us how fast the climate is shifting, where rain is falling, and even how hurricanes might behave. Salt is a silent guardian of our world's stability. Take it away, and Earth becomes unrecognizable. So the next time you stand by the sea and taste that salty air, remember, you're not just smelling salt. You're sensing a story of ancient rains, weathered rocks, living ecosystems, and delicate balances that hold our planet together. The ocean is salty not by accident, but by necessity. And if it ever stopped being salty, we'd all be in trouble.